think of it as a black box. I'll call it, it will project the vector for me. Okay, now what do? I have u1, u2. I take v3. What do? I project v3 onto, I'll project, okay, v3 onto v1 comma v2, okay, some span, some linear combination of this. So it forms a vector space. I'm going to project it onto that, right? This is a subspace, right? v1, v2 is a subspace. So I'll project onto that. Is that fine, everyone? So this projection will give me this vector, right? So if I project, what do I get? Let's say I get this vector. Maybe I'll use a different symbol. Maybe I'll use bar here, okay? So this will give me a vector, okay, which is here, right? What should I do now? What should I do? I should ensure that this is a unit vector. How do you know that this is a unit vector? Right? I don't know. It's not really a unit vector. So what should I do after this? Any idea? So I got this vector, right? I have to subtract v3 from that, right? So what do I get? Orthogonal. And what should I do? I should of v3 minus v3 to get what? u3, right? Now what do? You project v4 onto v1, v2, v3, subtract v4, divide by the norm. I get u4. Keep on doing that. Okay? Is that fine? Is that fine? Okay? Yeah. So now, okay, so now we need to look at what is this, right? So what do you mean by projecting onto a space, right? So what do you mean by that, right? So how do you project, and what do you mean by projecting onto this, and so on, right? So how do you ensure this thing, right? Let's look at this. So for example, okay, this again geometry, okay. Let's look at 2-dimension only. So if you are projecting, this is the point, right? When you project, you get this point, okay, or in other words, you get this distance, right? Length, right? Not really length, but this distance. If it is negative, we'll get negative, right? So that's what we have. Now, when you project, so what happens is, suppose if this is your projection, what will you get? You get this vector, right? But if it is here, you get this vector. Among the three vectors, which one will have, which one do you think have the smallest length? There is this vector, there is this vector, there is this vector. Let me call this one as 1, this one as 2, and this one as 3. Okay. So which one do you think has the least length? 1, right? So in other words, looks like if you project, it will have the least length, right? So now, you can actually prove that also, right? So how do you prove that? So for example, if I project, so this is, what is this, by the way? This is, if I call this as V and this as U, or the other way, let me call this as U and this is V. What is this? This is some alpha U, right? Do you agree? I'm just scaling it, but I don't know what that alpha is. But alpha U should be close to V, right? That's how I have to scale, right? So what is this problem? This problem leads to what? See, within linear algebra, there is an optimization problem, right?